am Nurfatin Shazwani, and now I will give you a simple briefing of introduction to the roots of polynomial. Firstly, a polynomial is a special kind of mathematical expression that looks like this. Secondly, if an is not equal to 0, then we say that the polynomial has degree n. Thirdly, according to the fundamental theorem of algebra, any polynomial with degree n has n complex roots, counted with multiplicity.
Now, let's look at the definition. The roots of a polynomial are called its zeros. It is because the roots are the x values at which the function is equal to 0. A polynomial is an expression that has two or more algebraic terms. As the name itself may suggest, poly means many and nomial means terms. Hence, a polynomial means it is an expression that has many terms. A polynomial has the following: variable, constant, and the exponent. Let's look at the three examples of polynomial to understand it in a better way. The first one, negative 5n plus 1, which is an linear equation. The second one, negative 8 power of 2 minus 5b plus 6. The third one, negative bracket 07 plus bracket 3 times 6 bracket minus 8f. From the example, there are constants such as 1, 2, 3, 5, 6, 7 and 8. The variables are a, b, d and f. The exponents are 2 and 7, as in a to the power of 2 and d to the power of 7. The constants can be any single or double-digit numbers. The variables can be a, g, m, n or p. The same applies to the exponents. It can be 1 as in n, 2 as in m to the power of 2, and so on. You can find the roots of a polynomial using several techniques. Factoring is also a method that is used. A graph is also in use to find roots of a polynomial. Here, we shall dwell on some frequent in use ways. Also, it is essential to bear in mind the following. The first one, polynomials are terms that only have positive integer exponents. The second one, polynomials get the operation of addition, subtraction and multiplication. The third one, it must be possible to write expression without division. Now, let's look at these three: exponent, degree and coefficient. An exponent is a power or the degree a number constant is raised to. For example, in a to the power of 2, the exponent is 2. In a to the power of 3, the exponent is 3. In a, the exponent is understood to be 1, which 1 usually is not written. While the degree is the value of the greatest exponent in the expression in the polynomial. We are not referring to the constant here. The largest exponent will tell you about the degree. For an example, in m to the power of 2 plus m plus 4, the degree is 2. Look at the largest exponent. In 11 m to the power of 2 plus 9 m to the power of 5, the degree is 5. Look at the largest exponent also. Lastly, the coefficient is nothing but a constant. It is a number before the variable. For an example, in 3g, 3 is the coefficient. Now, let's look at the roots of a polynomial. The roots of a polynomial are those values of the variable that cause the polynomial to evaluate to 0. You know that polynomials are the sums and the difference of the terms that are part of the polynomial expression. So, we can say that the roots of a polynomial are the solution for any given polynomial. In case of an algebraic expression, such as a polynomial that has constant and variables, we need to find the value of the unknown variable. We can find the value of a polynomial to 0 if we know the roots. A polynomial can be zero value, even if as constant that are greater than 0, such as 10, 25 or 46. Here, in such cases, we have to search for the value of the variables which set the value of an entire polynomial expression to a 0. These values are the roots or zeros of the polynomial.
Hi, I am Alia. I will explain about 4 methods to find the zeros of polynomial function. Before that, let's take a look at the relation between roots of polynomial and zeros of polynomial. The roots, sometimes called zeros or solution of a polynomial. Px are the values of x for which Px is equal to 0. Finding the roots of a polynomial is sometimes called solving the polynomial. So we can conclude that zeros of polynomial is the same as roots of polynomial. These are the methods that we use to find the zeros of polynomial function. First, factor theorem. Secondly, factoring. Thirdly, synthetic division. And lastly, Depress equation. What is a factor theorem? Consider a polynomial fx of degree n is greater to 1 or equal to 1. If the term a is any real number, then we can state that x minus a is a factor of fx if fa equal to 0. Proof of the factor theorem. Given that fx is a polynomial being divided by x minus c, if fc equal to 0, then equation fx equal to x minus c qx plus fc. Next, fs equal to x minus c qx plus 0. Lastly, fs is equal to x minus c qx. Hence, x minus x is a factor of the polynomial fx. The factor theorem is a special case of remainder theorem, which states that a polynomial fx has a factor x minus a if and only if a is a root, fa equal to 0. How to use the factor theorem? Let's take a look at the question. Find the roots of the polynomial fx is equal to x to the power of 2 plus 2x minus 15. From the solution, we know that s is equal to negative 5 or s is equal to 3. We can check if x minus 3 and x plus 5 are factors of the polynomial x to the power of 2 plus 2x minus 15 by applying the factor theorem. So we need to substitute s in the polynomial equation. From this question, s is equal to 3 and x is equal to negative 5. Since the remainder are 0 in the two cases, therefore x minus 3 and x plus 5 are factors of the polynomial x to the power of 2 plus 2x minus 15. Roots and factoring. When an expression x minus a is a factor of a polynomial fx, then fa is equal to 0. How to solve using factoring method? The zeros of a polynomial function can be determined easily if the polynomial is in a factor form, but the problem arises when the polynomial is expressed otherwise. The polynomial must be factored. From the solution, we know that we need to factorize the equation by grouping. Lastly, we need to equate factors to 0. Hence, the zero of fx are 1, negative 2, and 4. What is synthetic division? Synthetic division can also be used in determining the zeros of polynomial function. Recall when the remainder of a polynomial function fx when divided by x minus c is 0, then c is a zero of fx. How to solve using synthetic division method? Step 1. To set up the problem, first set the denominator equal to 0. To find the number to put in the division box. Next, make sure the numerator is written in descending order, and if any terms are missing, you must use a 0 to fill in the missing term. Finally, list only the coefficient in the division problem. Step 2. Once the problem is set up correctly, bring the leading coefficient, first number straight down. Step 3. Multiply the number in the division box with the number you brought down and put the result in the next column. Step 4. Add the two numbers together and write the result in the bottom of the row. Step 5. Repeat steps 3 and 4 until you reach the end of the problem. Lastly, write the final answer. The final answer is made up of the numbers in the bottom row with the last number being the remainder, and the remainder must be written as a fraction. The variables start off one power less than the original denominator and go down one with each term. So what is a depressed equation? When you divide a polynomial by one of its binomial factors, the quotient is called a depressed polynomial. How to solve using a depressed equation? Use static division to find the depressed polynomial. From the solution, we know that 2x to the power of 3 minus 3x to the power of 2 plus s are put into the division box. Depressed equation, as we know, we need to divide a polynomial by one of its binomial factors. From this solution, we get the depressed polynomial is 2x to the power of 2 minus s. A depressed polynomial may also be the product of two polynomial factors, which will give you other zeros of the polynomial function. In this case, 2x to the power of 2 minus s is equal to x2x minus 1. So, the zeros of the polynomial function fx is equal to 2x to the power of 3 minus 3x to the power of 2 plus s are 0, 1 over 2 and 1.
Now, let's look at the example question for each of the method. The first one, factor theorem. The second one, factoring. The third one, synthetic division. And the last one, depressed equation.
Hi, my name is Muhammad Haris Shafiq. So, I will be presenting about the polynomials real-life application. First of all, although many of us don't realize it, people in all sorts of professions use polynomials every day. The most obvious of these are mathematicians, but they can also be used in fields ranging from construction to meteorology. Although polynomials offer limited information, they can be used in more sophisticated analysis to retrieve more data. For an example, stock market. Polynomials can also be used to model different situations, like in the stock market, to see how prices will vary over time. Business people also use polynomials to model markets, as in to see how raising the price of a good will affect its sales. Other than that, we use polynomials in loan calculation and company valuation. Assessment of present value is used in loan calculations and company valuation. It involves polynomials that back interest accumulation out of future liquid transactions, with the aim of finding an equivalent liquid, which is present, cash, or in-hand value. Fortunately, numerous payments can be rewritten in a simple form if the payment schedule is regular. Tax and economic calculation can usually be written as polynomials as well. Next, since polynomials are used to describe curves of various types, people use them in the real world to graph curves. For example, roller coaster designers may use polynomials to describe the curves in their rides. Combination of polynomial functions are sometimes used in economics to do cost analysis. For example, engineers use polynomials to graph the curves of roller coasters and bridge. Roller coasters are modeled using polynomial functions, specifically this one, y equals to ax to the power of 6 plus bx to the power of 5 plus cx to the power of 4 plus dx to the power of 3 plus ex to the power of 2 plus fx plus g. If we fill in the values, we get this graph that's shown in the slides. As you guys notice, the graph is identical to the roller coaster. Next, we can use polynomials in healthcare. Nursing, psychiatric, and home health aides use polynomials to determine schedules and keep records of patient progress. People seeking employment in these areas require a keen mathematical background using polynomial computations. For instance, we can use polynomials in medical dosage to calculate the concentrations, which is C, in parts per million of a certain drug in the bloodstream after T, which is hours. We can use this equation. C equals to negative 0.05 T to the power of 2 plus 2T plus 2. Other than that, we can use polynomials to measure the weight of patient. The weight, which is W of a sick patient, can be modeled with this equation. W in the bracket of n equals to 0.1 n to the power of 3 minus 0.6 n to the power of 2 plus 110. N equals to number of weeks since patient became ill. Additionally, polynomials are used in physics to describe the trajectory of projectiles. Polynomial integrals, which is the sum of many polynomials, can be used to express energy, inertia, and voltage difference, to name a few applications. Polynomials also come up often in chemistry. Gas equations relating the diagnostic parameters can usually be written as polynomials, such as the ideal gas law, which is PV equals to nRT, where n is mole count and R is a proportionality constant. Electronics also use many polynomials. The definition of resistance, which is V equals to IR, is a polynomial relating the resistance from a resistor to the current through it and the potential drop across it. And last but not least, we can use polynomials in forestry, converting measurements using geometry to calculate area, and metric math applied to forestry employment in conservation work and logging. Forest engineers, conservationists, and loggers use polynomials in managing the land, for example, calculating how many trees to replant after cutting down a section of forest.
Question 1 for factor theorem. The equation of gx is equal to x to the power of 4 minus x to the power of 3 minus 11x to the power of 2 plus 9x plus 18. There are 4 zeros, real or imaginary. According to the rational roots theorem, the possible rational zeros are plus minus 1, plus minus 2, plus minus 3, plus minus 6, plus minus 9, and plus minus 18. So we will insert each of the plus minus to the x and find the value of the equation. If x is equal to minus 1, then the equation becomes 0. Hence, minus 1 is a 0 of gx. If x1, then the equation becomes 16. So, x1 is not a 0 of gx. If x is equal to negative 2, then gx becomes 2. So, negative 2 is not a 0 of gx. If x is equal to 2, then gx becomes 0. So, 2 is a 0 of gx. If x is equal to negative 3, then gx becomes 0. So, negative 3 is a 0 of gx. If x is equal to 3, then gx becomes 0. So, 3 is a 0 of gx. Hence, gx has only 4 zeros and we have already found 4. Thus, the zeros are negative 1, 2, negative 3, and 3. We also can solve the question using apps from the link given. Firstly, you can insert your equation. Then you choose how you want to answer the question, which is find the root zeros. So the apps will automatically give you the answer, which is the root zeros are the z values where the graph intersects the x-axis. To find the root zeros, replace y with 0 and solve for x, which is x is equal to negative 3, 3, 2, and negative 1. The apps also give you the example of the graph. Question 2 for factoring. To solve the equation, firstly using common monomial factoring, secondly factoring by grouping, and then equate factors to 0. Hence, the zeros of hash x are 0, -2, -3, and 1. From the apps, you can insert the equation and find the roots zeros. So the answer, the roots zeros are the x values where the graph intersects the x-axis. To find the roots zeros, replace y with 0 and solve for x. So the answer is x is equal to 0, 1, -2, and -3. For question 3 synthetic division, from the equation, there are 4 zeros, real or imaginary. The possible rational zeros are plus minus 1 over 2, plus minus 1, and plus minus 2. If fx is divided by x plus 1 over 2, since the remainder is not 0 but negative 15 over 4, minus 1 over 2 is not a 0 of fx. Using the same way, find the remainder of negative 1 over 2, plus minus 1, and plus minus 2. Hence, fx has 4 zeros and we found only 2 real rational zeros. The other 2 zeros are not real rational, they may be imaginary. Thus, the real only rational zeros are 1 over 2 and negative 2. From the apps, the root zeros are the x values where the graph intersects the x-axis. To find the root zeros, replace y with 0 and solve for x. So the answer is equal to 1 over 2 and also negative 2. Question 4 for the first equation. From the equation, the possible rational zeros are plus minus 1, plus minus 2, plus minus 3, and plus minus 6. So, if fx is divided by x plus 1, since the remainder is 0, negative 1 is a 0 of fx. So the first equation is x to the power of 2 plus 5x plus 6 is equal to 0. To find the other zeros of fx, solve the first equation by factoring. Thus, the zeros of fx are negative 1, negative 3, and negative 2. Using the apps, the root zeros are the x values where the graph intersects the x-axis. To find the root zeros, replace y with 0 and solve for x. Hence, x is equal to negative 1, negative 2, and negative 3.
In conclusion, polynomials are one of the most important topics in mathematics. For this reason, it is important that we learn polynomials well. Moreover, polynomials are great ways to develop a particular thinking skills. Polynomials should be studied both because they are one of the most frequently discussed objects in mathematics and because they are one of the most interesting. And that's all from us. Thank you.